Okay, so we're going to do a session on transformation of graphs, and before we look at the past paper questions, I'll just give you some background about functions, which you will, if you choose to do A-level maths, become very familiar with. There's a lot of work regarding functions in A-level, but in GCSE now, all you're interested in is knowing how to move them around a graph. But at its simplest level, a function can be considered just as a number machine. So for example, if we go back to the sort of key stage 3 number machine ideas, you'd have an input that would go into a machine which would do something. So let's say, and I'll use this as my example, a squaring number machine. So you're going to put a number into that, it's going to go into there, get squared, and produce an output. So if you put the number 1 in, 1 times 1 is squaring, out comes the number 1. If you put the number 3 in there, 3 times 3 would be what the machine did, 9 would come out. If you put negative 2 in, negative 2 times negative 2 is what the machine would do, and out would come the number 4, and so on. So that is a function. It's a piece of maths that is taking an input, doing some maths to it, and generating an output. Now, the way that we would write that as a function rather than as a number machine would be that the input would be x, the number machine would be written like that, some function of x equals x squared, and what come out will be y equals fx. So if we put the number 4 into it, this would become f of 4, which would be 4 squared, which would give us 16. If we put the number negative 5 into it, we would write that as f of negative 5, which is minus 5 squared, which is plus 25, and so on. So that would generate this idea of f bracket x. And if we put y equals to it, then what it's giving us is a coordinate pair, an x coordinate which we could plot against a y coordinate. So if we stick with the x squared as our function, then what we've got here, so if fx is x squared, negative 3 is going to be minus 3, negative 3 times negative 3, which is plus 9, plus 4, plus 1, 0 squared, 0 times 0 is 0, and then 1, 4, and 9. So that would give us a set of coordinate pairs which we could plot. So on the graph above, x is negative 3, y is 9, negative 2 plus 4, negative 1, 1, 0, 1, 4, and 9. So hopefully you're familiar already with what the graph of y equals x squared looks like. So that's good enough. Okay, so that's the graph of y equals fx when the function is x squared. Now, with these transformations of graphs, they're not, or it's unlikely they're going to expect you to accurately draw a graph in the way that I have there. What tends to happen is they'll give you the graph, or they will expect you to know that it's the graph of x squared, and then they'll ask you to do things with it. So let's say, for example, that what they will want you to do is that. So what that is saying is that you will be adding 1 to the output. So if x is -3, the output is 9, and you are then going to add 1 to it. So basically that's a machine which is doing this. It's bolting this extra little bit onto your machine. So the input is 1 or 2. You're working out what the corresponding coordinate is, and then you're adding 1 to it. So what effect that would have on those is it would change that to 10. So that one would go up 1. +4 would become +5. +1 would become +2. Can you see that all that's happening, 0 would become 1, is that that transformation takes your original function and moves it up your graph. Or if that was -1, it will come down your graph 1. If it was +10, it will go up 10. So if you've got f of x and then you're doing something with it, so if I generalize that up here, so if you've got y equals f of x plus or minus some value a, then it's going to move up or down your y-axis. So that's one of the transformations that you need to know about. Another one that you need to know about is, what if, rather than having the +1 there, the +1 is inside the bracket. Now what that is doing is adding 1 to your input before working out your output. So as a box, as a number machine, that's doing this. So it's adding 1 to your input before working that out. So what that will do is, let's say that we're starting with an input of 1. The input of 1, you're adding 1 to give 2, and then squaring it. So 1 becomes 4. You put in 2, you add 1 to it, you get 3. Square it, you get 9. So it has the effect of that. If you're putting in 0, you're not getting 0, you're getting 1. So basically what this is doing is moving these points, 1 unit that way. So this one here will become 2, which is there. So if you're adding 1, the effect that it's having is it's moving 1 unit in this direction. So if that was an x minus 1, it would have the impact of moving it 1 unit in that direction. So y equals f of x plus or minus some value. If it's adding, you're moving it to the left. If you're subtracting, you're moving it to the right. Moves. So if it's a plus a units to the left, or minus a units right. Okay, so just clarify that again. If the plus or minus is inside the function, it means you're adding to the input, not the output. So it means that whatever was 0 becomes the output to the next one along. The next transformation that you need to know about is what happens if you've got a minus sign in front of the function. So what happens if it becomes negative? Well, again, what this is doing is taking the output and making it negative. So the output of 1 would become negative 1, the output of 2 would become negative 4, and so on. So what effect that would have is 1 would become negative 1, 4 would become negative 4, and there's not enough room on the paper, but hopefully what you can see is what that's going to do, if I just do a little sketch down here, is it's going to reflect your curve, because the output, the input is 1, the output becomes negative 1. The input is 2, the output becomes negative 4. It's forcing it to the opposite. So what y equals f minus fx does is reflect the graph using the x-axis as a mirror. So if you've got minus fx, you're going to reflect your curve, whatever curve you've been given. Another one that you need to know about is y equals, let's say we do 2fx, then what that is going to do is double your output. So 1 becomes 2, 2, 4 becomes 8, 9 becomes 18. So y equals 2fx takes your output and doubles it. Takes your output and doubles it. So what that does, but it's still going to go through 0, so what that does is increase the gradient. So what was like that now becomes much steeper, so it doubles the gradient. So it makes it steeper. So if that was a half, it would make it less steep. So y equals afx increases gradient. I think that those are the main ones that you need to know about. Okay, so to go through them again, that one is going to increase your output. It's going to add or subtract your output, so it's going to move up and down the y-axis. This one increases your input, so moves it across the x-axis. That reflects, that increases or decreases the gradient. Okay, so that's basically what you need to know before you start answering the questions.